All right, we are going to get going with the Flash Talks. This is session 1 of Flash Talks. Thanks everyone for being here. I'm Ali Kasiba from UVM Extension. This is going to be rapid fire. These are 7-minute talks, 3 minutes for questions. So we're going to be going through them pretty quickly. We do have a cancellation. Unfortunately, Bob Fahey had a family emergency and is not able to come. So we are going to bump up folks a little bit. It might allow for a couple extra seconds for questions for each person. But we're going to start off with our first presenter. Lina Clifford from the University of Massachusetts is presenting on New England family forest owner attitudes towards passive forest management options. Thanks, Lina.
All right, hi everyone. I'm excited to share with you my thesis research while I've been a master's student at UMass. I've been working with Paul Catanzaro, who's my advisor, and Marla Murkowski-Lindsay, who is on my committee, and this work has largely been done along their side. To begin, we were thinking about passive forest management because passive and active forest management are along this spectrum of management options when it comes to ecological forestry. As we've been talking about this morning, there's a variety of forest benefits to sustain through our management practices, and we need both, from all the way passive to the most active strategies in order to meet that diversity of forest benefits. We know that family forest owners play a really important role in this because they own so much of our forests in the Northeast and New England in particular. And because active forest management strategies have long been recognized as a way to maintain forest benefits, there's a lot of great research about family forest owner attitudes towards active strategies. There's nothing to date, though, in the US looking at family forest owner attitudes towards taking a passive approach. Importantly, I want to be clear that when we say passive, we mean taking an intentionally passive approach, deciding that that's the management strategy that you're going to use on some or all of your land, not passive in the indifferent, I haven't thought about it sense. So to investigate this and to answer how do family forest owners feel about this, we developed a survey and sent it out to 2,600 family forest owners in New England. We had 4 main research objectives here. First, we wanted to know about the scale and scope of family forest owner interests in passive forest management, their preference for different tools that they could adopt passive forest management, the characteristics of family forest owners that increase or decrease the intent to adopt passive, and then lastly, the concerns and benefits that family forest owners perceive when it comes to applying passive forest management on some or all of their land. This is our definition that we used in the survey. This largely came through conversations with John Leibowitz at the Northeast Wilderness Trust. The main idea here is that timber harvesting is not allowed, motorized vehicle recreation and building structures is not allowed, while hiking, snowshoeing, invasive plant management, collecting berries and sap for personal use, and hunting are all allowed within this definition of passive forest management. In our survey, we asked about a lot of different things. We collected a lot of data, but the meat of the survey were these 4 hypothetical scenarios through which the respondent could hypothetically adopt passive forest management on some or all of their land. The definition of passive stayed the same, so that slide that we just looked at was the definition across all 4 scenarios, but the things that did change are at the top of that table there. So we gave folks a voluntary scenario where they would just decide on their own to adopt passive forest management on some or all of their land, a current use property tax incentive program where they would be enrolled in a formal program and they would receive a significant property tax reduction for managing their land passively, a conservation easement scenario, and then a fee-simple land sale scenario where the respondent could sell their land to a conservation organization who would then manage it passively into the future. So when it came to the scale and scope of interest, 36% of our respondents would do at least one of the scenarios that we posed to them with certainty. 21% of our respondents rejected all of the scenarios. 38% were uncertain or rejected some of the scenarios. And then 5% simply didn't answer the scenario questions, but answered other portions of the survey. So this 36% has a bit of nuance to it. Not everyone wanted to adopt passive forest management on all of their land. It actually turned out that significantly more of our respondents were interested in adopting passive forest management on some land only, never all of their land. We found this really interesting because we weren't sure if people would be thinking about their land in this way, about dividing up management, but it turns out they were. There's a dedicated portion of our respondents, that 12% who are interested in adopting passive on all of their land, but most folks were more interested in adopting on some. We also were able to find that 21% are reporting that they're already doing passive forest management through one of the 4 scenarios. This also hasn't really been quantified before, so this was really interesting to see. When it came to the tool preference, this is a chart showing the 4 different scenarios, starting with voluntary on the left, current use, the easement scenario, and then the fee simple land sale. By far, the most popular scenario for adopting passive forest management was that current use scenario. This makes sense because there's a combination of a temporary approach while also getting a financial benefit with that property tax reduction. The least popular approach was the fee simple scenario. And then for the folks who are already doing passive forest management, voluntary, thank you, through this voluntary scenario. So they're not enrolled in a formal program of any kind, and this could stop at any time. We gave folks a sort of grocery list of potential concerns and benefits they might have about the passive approach through some key informant interviews that we did at the beginning of our process. Most folks had concerns. Most folks saw benefit to the passive approach. The top 2 concerns, no matter which way we slice the data, folks who are interested in passive, those who rejected all of the scenarios, were the firewood restriction and limiting the land use for future owners of the land. And then similarly, no matter which group we looked at, the top 2 benefits were old forest habitat and letting nature take its course. So thinking about this on the landscape, instead of thinking about active and passive as sort of opposed to one another, like black and white, here you can think of the black polygons as reserve areas and then intensively managed silvicultural sites. We can think of them as shades of green along a spectrum, and family forest owners can fill in this in-between matrix between these reserve areas and intensive production sites. We see that 12% of our respondents are interested in adopting passive on all of their land. Significantly more were interested in adopting passive on some of their land only. And then 21% were just not interested in any of the scenarios that we gave them. And then the land in between is those folks who are uncertain. And so that could be for a variety of reasons, whether the scenarios that we gave them didn't match their goals. But these folks are undecided. But you can see here there's a lot of land to engage through a variety of forest management options to sustain the forest benefits that we rely on. I'll just end with some acknowledgements here that you can read on the screen, and I'm happy to take any questions. I'll go with, yeah.
If you go back one slide to the map,
Mm-hmm.
are those actually representative of how the folks answered tied to their land?
So I use the proportion of our respondents and the proportion of family forest owner land in this study area to draw an example. So this isn't the actual respondents themselves, but just the proportions to kind of draw a picture. Mm-hmm. Yeah.
Do you know what proportion of the respondents lived on the land?
The majority of them lived on their land. I think it was 73% lived on their land. Mm-hmm.
Did you do any analysis based on parcel size?
Yeah, so we did some modeling that I didn't have time to talk about, looking at what factors turned up or turned down adoption of the specific scenarios. And we included acreage in that analysis, and it wasn't significant in any of the models that we ran. Sure.
Level of forestry knowledge or experience?
Yeah, that's a great point. That wasn't included in the survey. It's a tough balance between including all the variables you want and making sure it's short enough for folks to take it, but that's a great thought if we could do it again, for sure. Yeah.
What about second homeowners versus primary residents?
That's something that has been brought up before when we've shared this research, and that wasn't something that we included, but certainly I would also think that would have an effect. Yeah. Anyone else? Okay. Thank you.
All right, the next flash talk we have is Ken Laustsen and Lloyd Irland, but he's not here, Lloyd's not here, semi-retired professionals from Maine, and they're going to be talking about local woods works, supporting conservation of local wood processing operations.
Good afternoon. Both myself and Lloyd Irland serve as consultants to the local woods project in Maine. We have three focuses: conservation of forest land, sustainability, and improving local wood processing operations. Advance. Thank you. So local, we use the term in the broad sense. It's not just Maine. It's New England, the bordering Canadian provinces of Quebec, New Brunswick, and New York. We have 8 partners that have committed to promoting the below ideas. Our partners include the Kennebec Land Trust, the Maine Forest Service, the Nature Conservancy in Maine, Maine Coast Heritage and Trust, Coastal Enterprises, the Northern Forest Center, and MOFGA, the Maine Organic Farmers and Growers Association. To date, our efforts have been supported by the Elmina Sewell Foundation, and what we are committing to promote is sustainable forestry, land stewardship, strong and resilient local economies, conservation of both working woodlands and ecological reserves, reduced energy consumption and transportation, because we want to base our consumption on local products, and then support for a suite of people: landowners, loggers, processors, manufacturers, and consumers. The project started in 2014. Since then, we've had a variety of outreach efforts. In 2014, we hosted the first Local Woods Works Conference in Augusta, Maine. We had over 100 people attend from across Northeast and New England. And we had a discussion on presentations focusing on how local wood economies work. In 2016, we hosted 4 sector meetings where we targeted single groups of participants to discuss these topics: forest management and harvesting, design and construction, manufacturing, and then policies and partnerships. Over a 6-year period between 2017 and 2023, we hosted 5 bus tours. Each tour was 1 to 2 days long. Each tour always included an active harvest operation, a visit to a primary processing plant, a visit to a secondary processing plant. So a primary plant was a sawmill, a pellet mill. Secondary processors included a turnery mill, another business that just did flooring. So we exposed people to a variety of businesses out there. And we also included an example of an energy efficient or sustainable housing type construction. So over those tours, we actually visited 21 different businesses, and we had 70 participants. The amazing thing about that is the people that participated in the tour started to put together how long it takes to go from a stump to the dump and everything in between that's involved in producing a wood product. Our coordinator over a 5-year period did lunch and learns. He would actually go to architect firms in southern Maine and explain to them local wood and how architects can help promote the use of local wood, and how architects can connect to local wood supplies. And then last spring, we had a local wood roundtable, which was a one-day meeting where we convened a group of interested people to talk about our missions and programs. We're trying to widen our awareness of what we're doing and to seek additional cooperators and ideas for activities. The report out of that roundtable was issued in January this year, and it can be accessed at the below Local Woods website. Our strategy: 3 types of local wood. Real local is 100 miles that has been produced using sustainable forestry practices. Maine wood is from Maine, again, sustainable forestry practices. And then regional wood within New England, New York, and Canadian provinces. One of our key components is sustainability, which we also have a position paper on. Sustainability in terms of forest management is one of the hardest topics I've ever had to describe to non-foresters. How do we support local economies? We promote environmental stewardship, carbon storage, most importantly, keeping forests as forests. And then we provide so by promoting local economies, local mills now have access to a more sustainable supply of quality forest products. And then trying to connect architects, builders, homeowners to find local wood. This supply chain compliments of the Forest Resources Association shows how hard it is and how long it is to go from planning a harvest operation to getting a final product. This is also a difficult concept for non-foresters to understand. It's a difficult concept for architects to understand because they expect to go to Home Depot and get exactly what they want while they're there, and it just doesn't happen. So helping architects understand that the rarer the species, the bigger the piece, the longer it's going to take to get it. So that's local wood, a project in Maine. Local wood does work, and we're trying to keep it working. Thank you.
Questions?
Yeah, I haven't read your paper, but I'm looking forward to reading it. What about cost? Because most people, they're building, it's the biggest expense they're ever going to face. They just want the cheapest stick they can get. But if it's competitive or not?
That is a challenge in that, you know, whether you're an architect, a builder, or a homeowner, you're looking to do a project at the cheapest cost. And to some degree, our current economies don't totally represent the environmental cost of accessing Douglas fir plywood or teak from South America. So we recognize that problem. We don't really have a solution to it, but when people need to be more aware that they can actually go to their local sawmill and get a perfectly serviceable 2x4 rather than Home Depot. So that's more the concept we're trying to bring forth.
Thanks, Ken. Uh-oh, I lost my mouse. All right. Well, thank you for your help. All right, our next speaker is Rachel Swanwick. Where are you? Oh, there you are. She's going to be talking about improving cross-cultural, collaborative, socio-environmental approaches for knowledge exchange and forest stewardship across tribal nations and state agencies in Maine, in the United States. Great. All right. Thanks, Rachel.
Excuse me, sorry.
Okay, hi everyone, I'm Rachel Swanwick. I'm a master's student at the University of Vermont, and I'm going to be sharing my research on improving cross-cultural collaborative approaches for knowledge exchange in forest stewardship. All right, so to get started, I'm going to share an infographic that I developed to try and illustrate in a nutshell the background of my research. This might be kind of hard to see the full scope of the infographic in the back, but I'm going to kind of talk everyone through it. So starting in the middle, forest systems will face a range of social, ecological, cultural, and economic challenges that are going to require adaptive planning and action by forest stewards across multiple spatial and temporal scales. This is going to affect diverse property boundaries. So, for example, some of these challenges include tree mortality from climatic stress, a shortened harvesting window, threats to cultural lifeways like basket making, impacts from freeze-thaw cycles, risk from invasive species, and also forest pests. So despite all of these challenges, diverse knowledge systems offer different lenses to help us respond to some of these challenges. Some of these knowledge systems include local knowledge, indigenous knowledge, and Western scientific knowledge. And it's important that we try to find opportunities to facilitate equitable exchange between these different knowledge systems so we can better bridge different knowledge systems to generate insights for climate adaptation. However, the practicality of equitable knowledge exchange is really complex, and it's also context dependent. And that is why cross-cultural collaborations between different organizations and the actors within them offer a really great pathway to try and maximize knowledge exchange to help inform adaptive actions across the landscape. And this is what my research tries to explore. So in thinking about some of these important relationships, there has been extensive research on federal tribal and federal state relations, but what hasn't been explored in much depth is relationships between tribal nations and the state. And so that's what my research looks at. This is one of the most challenging types of relationships. It's very complicated and also highly variable across the landscape. And in present-day Maine specifically, there are ongoing challenges between the state and tribal nations regarding natural resource management, tribal sovereignty, and land access, all of which impact the adaptive capacity of the state and the tribes. So my study explores state-tribal relations in present-day Maine, where 89% of the landscape is forested. In Maine, the Wabanaki Nations are a confederacy of tribal nations. The map on the right here shows where those tribes' reservations are located throughout the state. There are 4 federally recognized tribal nations in Maine: the Penobscot Nation, the Passamaquoddy Tribe, the Micmac Nation, and the Holton Band of Maliseet Indians. For these tribes, forests play a very important role in supporting their multifaceted connections with cultural lifeways like basket making, valued ecological resources and materials, knowledge systems, and economic development. So for forests are very important pathways to sustain tribal community well-being overall. Given this background, my research goal is to evaluate how forest stewards from state agencies and tribal nations in Maine understand and value diverse knowledge systems related to forest stewardship, and describe ongoing tribal-state relations in the context of knowledge exchange, collaboration, and climate change adaptation. So how did I do this? I interviewed forest stewards from state agencies and tribal nations. I interviewed 22 forest stewards in total, 12 participants who were employed at state agencies across Maine, 3 different state agencies, and 10 participants across all 4 Wabanaki nations in Maine. Those participants were either employed by the tribal nation, or they were tribal members, or both. Interviews lasted between 45 and 150 minutes with participants, so there was quite a lot of data to sort through. And I'm going to jump now into my results. So firstly, I'm going to look at participant values and beliefs about knowledge and knowledge exchange. So among state agency participants, they often cited that Western knowledge was the primary knowledge source that they used to help establish certainty and validity in their adaptation planning and implementation. But beyond Western science, participants also shared that they valued a diversity of knowledge sources, and this helped to enrich their resiliency in dealing with complex problems. One state participant said, "No one source is ever going to give you the complete answer. What happens in the ivory towers of universities is not always reflective of what people observe on the ground. However, due to some barriers that I'm going to discuss in the next section, state participants had limited engagement with Indigenous knowledge and more often pulled from local knowledge to inform their decision-making and their management. Among tribal participants, they explained that there was a sense of collective and individual responsibility towards Indigenous knowledge. This includes stewarding culturally important places and species to help meet the priorities of their community. But this doesn't mean that Western science wasn't also valued. All my participants were trained in Western academic settings, and they really valued Western scientific information to inform their stewardship. A tribal participant shared, taking every perspective into account is part of this job, using the best science available and also remembering where we came from. This led to a feeling among participants, though, that they were often straddling Indigenous knowledge and Western scientific knowledge when they were trying to meet their objectives. So kind of being pulled in both directions, trying to make sense of these different sources of knowledge. Next, I'm going to look at participant perceptions of collaboration between state agencies and tribal nations. So among state agency participants, there was a great interest in expanding projects where they could partner with tribal nations. Despite this interest, there were various constraints to working together. The first of which is that due to some of the socio-political tensions that were happening at higher levels of state government in Maine, there was a fear that trying to build relationships would actually exacerbate ongoing issues. One participant shared, "I wouldn't know what the appropriate way to reach out would be. I don't want to contribute to any sort of negative interactions or experiences." This was ultimately informed by a lack of institutional guidance from the state at large and the state agency on how to approach building these cross-cultural relationships. For tribal participants, their approach to relationship building was less focused on specific projects and more focused on maintaining lasting relationships over time. They also identified many constraints to working across cultures. Similar to state participants, they shared that socio-political challenges eroded trust in state government. And they also identified a lack of knowledge about tribal affairs and relations among state agency staff, which stifled their ability to collaborate. A participant shared, "It's always like there's an elephant in the room when you have these conversations. There has clearly been issues over the course of history. I think it should be a big point to educate state workers about that." So based on these results, what were some key takeaways? So firstly, knowledge exchange is a two-way process. Tribal participants suggested that their non-Indigenous partners deepen their understanding of tribal relations in Maine. I suggest a further examination into some of the dominant institutions and biases that might inform how you build relationships. This could be facilitated by external trainings on cultural competency and unconscious bias. I also suggest that collaboration is most successful when it occurs at the outset of a process, whether that's like trying to put a project together or also looking for funding, for example. So this means that you need to have these collaborations at the onset of the process to facilitate equitable knowledge exchange and cooperation, and this happens through co-creating institutions together to help guide how you go about these processes. And then lastly, our study provided evidence that effective cross-cultural collaborations must include a range of knowledge holders beyond conventional Western paradigms. So moving beyond, foresters and natural resource managers, as important as we all know that they are, it is also really important to include other types of individuals like tribal elders, youth, Indigenous knowledge holders, people that bring a whole variety of perspectives to the conversation. With that, I want to thank my advisors, my collaborators, all at the University of Maine who have been so supportive and helpful, my research, my study participants who shared their stories with me, and all my funding sources. So thank you. Questions? Yeah.
I missed the last slide down the bottom. You listed tribal elders and institutional knowledge keepers separately. Who else besides the elders?
Who else?
Who else are the keepers besides the elders?
So for example, like artisans, maybe like a basket maker, medicine people, traditional harvesters. So people that have different roles in the community that might not be considered like tribal elders, but also possess a lot of really important knowledge, especially around forests. Yeah.
Do you have any plans to increase the sample size?
I don't, just because it's the scope of my master's research, but in terms of making sure that the sample was representative, I did do an approach called theoretical sampling. So you make sure that with the addition of different interviews, it's theoretical saturation. So I've reached saturation looking at, with the addition of new interviews, I was not achieving any more themes. And so at that point, it kind of became clear I didn't need to add more people, but even so, I added like about 10 or 15 more interviews beyond when I reached theoretical saturation to make sure that I could, talk to as many folks as possible. Yeah.
Coming out of this project, what gives you hope for the future?
I think there was so much interest among participants to try and work together. I think there was this shared vision of, being able to work together, having healthy forests in the future, and it seems like that's the direction that we're all moving. Even the conversations here at the conference, people are talking more about Indigenous knowledge and tribal nations, and just like bringing those voices forward, I think is a huge step forward. Okay, thank you.
Appreciate the tech help. Great. Such a nice variety of talks we're having here. This is so interesting. All right, well, next up, we have Skylar Roach. Where are they? Coming up. All right, from the U.S. Forest Service Northern Research Station, I think based in Maine, correct? And they'll talk about how the Grinch stole spruce. Love this name. The case study from the Blowdown following the 2023 Grinch storm.
Hi everyone, my name is Skylar Roach. I'm the forester at the U.S. Forest Service, Penobscot Experimental Forest, and I just want to take a second to thank all my co-authors. Their help has been, as always, amazing. And just to ground us in some background, the Penobscot Experimental Forest is about 4,000 acres in central Maine. It's run with the University of Maine and the U.S. Forest Service, where we have a 70-year-long silviculture experiment, and we're within the Acadian northern conifer forest type, which is dominated by red spruce and balsam fir. We also have representation from hemlock, cedar, pine, and then occasional hardwoods. And as you can see here, that the yellow star is where we are in Maine, and the red star is the management unit that this case study is about. So some timelines on the stand. From the 1950s to the 1970s, it was managed as a regular 3-stage shelter wood. In the 1980s, there was a PCT done, and then in the 2000s, this one big stand was split into two, and the one we're focusing on, they did a series of commercial thinnings to different residual densities in different areas of the stand as part of the CFRU Commercial Thinning Research Network. And so this left us with variable conditions within this stand, and we wanted to take advantage of this and try sort of a new treatment. And that treatment ended up combining thinning to pre-salvage spruce, to pre-salvage fir and release spruce and pine crop trees, while taking away patches of overstory with overmature fir. And this harvest happened in December of 2022. In January of 2022, there was a minor blowdown event, literally the day after the processor left. And in December of 23, the Grinch storm hit Maine, and we had a much more significant blowdown event. And I want to define blowdown event as sort of all mortality from the storm. Usually we break it up into breakage or leaning or uproot. In this case, breakage was like 9%, so we just clumped it all together for the sake of simplicity. And the Grinch storm had max wind speeds of 68 miles per hour. In the nearest large town, there was 2.5 inches of rain in 24 hours. And according to a survey done by the professional logging contractors, there was about 5.5 million in total losses to Maine's economy from the timber industry, and that's just in damages and harvest interruptions. That doesn't include stumpage values that were lost. And these storms are becoming more common. They're expected to be more common, so what used to happen every 50 to 100 years may happen every 1 to 10 to 5, who knows. And so this is a map of the stand. The red is where the worst of the blowdown occurred, and this little graph here just shows the direction of the blowdown. So it sort of blew right through the stand. Before anybody asked, slope was 4%. Just putting that out there. So the objectives of this case study were to quantify the blowdown and consider the possible connections between our application of an irregular shelter wood and the blowdown. And we assessed this using a reduction in basal area by species composition change, and then we also briefly looked at height and diameter ratios and percent removal. So As part of our regular inventory, we take pre-harvest and post-harvest data, so we had that already. And then when this blowdown occurred, there was a request by our Maine cooperators to do a salvage harvest, so they quickly went out and did a blowdown measurement, measuring all trees with a diameter greater or equal to 4.5 inches in these permanent plots that was leaning, uprooted, or broken off because of the storm, and we measured direction, diameter, and height. Shout out to UMaine student crews. They are awesome, and they did all of that in the middle of winter. So really quick, this is the pre-harvest and post-harvest data. Basically, it was a 34% reduction in BA from the harvest, and the biggest effect was in fir, with some hardwood removal, and no spruce. We don't harvest spruce unless it's absolutely ready to be harvested. It's really hard to retain in our forest. And this is looking at the blowdown data specifically, so again, that post-harvest data. And pre-harvest spruce was 35% of live basal area. It was 58% after the harvest and after that first blowdown, which caused small losses of fir and spruce, but primarily in the pole and saw timber, while this second one caused much more extensive damage, particularly in saw timber spruce, which is exactly what we were trying to retain with this variable thinning harvest. So if this was a commercial property alone, this would be an absolute failure, but luckily we do research. So, oh, and it was 76% of all the blowdown was spruce. So that's a lot. And I did briefly look at percent removal with trees blown down per plot. This is a really small data set, so all I can make is suggestions, but it suggests that with more removal, more blowdown, which kind of makes sense. We also looked at height and diameter ratio very briefly. The average was 79:1, and we saw an overall downward trend between HDR and blowdown. And this kind of matters because right across the road from this unit is the other half, and this stand was not a part of that CT and PCT study. There was no thinning in it previous to this harvest. This was harvested in the same year. We took out the same amount of basal area, and the only major difference between the stands was more pine and smaller crowns. The pine in the one that had a lot of blowdown was removed during those commercial thinnings, just for the record. And while usually we think that a bigger crown is more stable, in these non-uniform spatial distributions, it clearly opens up at least this stand to vulnerability. And in conclusion, so even after the PCT and CT, spruce retention in an ISNW stand like this one could increase blowdown risk during extreme weather events, caveat on extreme, and rooting depth was restricted in this site to quote our university forest manager, Keith Canody, it's ledgy. And so that can be a big concern, and it's especially concerning because spruce is a 2-rotation species, and it's way more difficult to sustain than fir. We don't manage for fir, it just happens. And additional research is definitely needed to determine the thresholds for reducing risk. Thank you guys so much. Any questions?
Did you do any measurements, or do you have any sense of what blowdown is like in nearby unharvested areas?
No, but in the stand right next door that just had the thinning, there was like no visible blowdown that we looked at, so we didn't do any measurements in it because there was no blowdown as far as we could tell. Yeah.
Was the ledgy in the adjacent stand?
Yeah, they basically have the same site conditions. I think the other stand even has a little bit more slope, if I remember correctly. Yeah.
Did you monitor the percent of basal area in stem breakage versus uprooting?
Yeah, so the breakage was about 10% of what blew down from the storm, and leaning or uproot was 90%-ish. Thank you, guys.
All right, so as I mentioned, Bob Fahey wasn't able to be here, so we're gonna keep moving with our talk. So Peter Breigenzer, sorry if I, if I got that right, from the University of Maine, talking about silvicultural options for climate resilience in northern conifer forests, the SEED project.
Thank you. Just give me 1 moment.
Hi, everybody. I'm Peter Breigenzer. I'm a staff research assistant at the University of Maine, and I'm here to share a newly funded project from the Northeastern States Research Cooperative. It brings together a really exciting multidisciplinary team from folks from the University of Maine, the U.S. Forest Service Northern Research Station, and the USGS. We're still in the planning stages for a lot of parts of this project, so we're open to feedback. The study is taking place in the northern conifer forest, which is historically known as spruce fir, includes other associated species. It's also called the Acadian forest, so that map shows the extent. Red spruce is the dominant spruce. Associated conifers include balsam fir, hemlock, white pine, and cedar. Hardwoods include maples, birches, aspens, ashes, and red oak. Thanks, Skylar, for the teeing up the northern hardwoods, or northern conifers. So this is a study about adaptation and resilience to climate change. Models show a warmer and wetter future for our region with increases in extreme events like windstorms and flooding events. Also the potential for droughts interspersed in between these events. These are the sort of abiotic threats that we're planning our treatments around. So there are three major components to this study. First one is a silvicultural experiment. The second one is a social study. And the third one is focused on communicating our findings to landowners and managers in the region. For the sake of this talk, I'll mostly be focusing on number one, because that's most of what we have planned so far, but I'll touch a little bit on number two. So this project is taking place at the Penobscot Experimental Forest. Oh, video didn't download. It's all right. This is a long-term silvicultural research station in central Maine. The part of this study will be converting about 350 acres of stands that were historically in other studies, and those are outlined in the boxes on the map there. These stands, much like much of the northern conifer region, have history of repeated partial harvests, which has led to a multi-age forest structure, which gives us a lot of flexibility moving forward with our treatments, where we can either keep them multi-aged or convert them to even-aged. So these graphs show the current species composition in these stands that will be used for the study. On the left, you can see overstory and saplings, and on the right, we have seedlings. On the bottom axis of these graphs, we have species, and on the y-axis, we have percent abundance. So you can see that most of this area is hemlock dominated, with smaller portions of red maple, red spruce, balsam fir, cedar, and so on. I think a lot of us are familiar with this concept of climate change winners and losers. So these climate ratings taken from the Climate Change Tree Atlas adaptability ratings are used to color the graph here. But one thing that those ratings don't often take into account is pests and disease. So we have a number of damaging agents that are either in our forest or nearby. We currently have balsam woolly adelgid in our forest, as well as beech leaf disease and beech bark disease. While hemlock woolly adelgid and emerald ash borer are not currently in our forest, but they are in the state and knocking on the door. So we are still defining a range of treatments that will cover a spectrum of canopy disturbance. We eventually will implement a total of 4 to 5 treatments likely that will address a range of objectives. And for each treatment, we'll have both stand-level adaptation objectives as well as carbon management objectives. And these are just a few examples of how we can address those objectives across a range of canopy disturbance. So just for example, on the far left side there, for treatments that have higher residual basal areas, we're likely to seek to maintain more of our vulnerable shade-tolerant species while focusing more on storing carbon in the forest. Where on the other end of the spectrum, with treatments with higher removals, we'll likely promote more warm-adapted species while focusing more on storing carbon in harvested products. And there are a number of regeneration methods and intermediate treatments that we can use to achieve these objectives. And a big portion of this project will be ensuring operational feasibility by defining these treatments alongside our forest manager partners who are working on the project with us. And we're working to further ensure operational feasibility by doing economic analyses that'll provide insight into those. We do plan to plant in this study, either by bringing in species that are currently outside of our forest but may migrate here due to climate change, assisted migration, or we may expand populations while planting species that currently exist in the forest but planting genotypes from more southerly populations. Response variables for these treatments will include your typical forest structure and composition, soil health, wildlife habitat, as well as monitoring some of the pests and disease, so we can see how they move into and through our stands across a range of different treatments. And I'll just note, for the sake of this, I think the untreated control provides a particularly interesting type of treatment in that it's historically been harvested, but if we essentially defer harvest starting now, it provides sort of a lens into what like a carbon management stand would look like alongside these more actively managed stands. So in general, our ability to implement these treatments and promote climate resilience depends largely on social acceptability, especially when it comes to certain aspects of forest management like herbicide use and certain types of harvests. Spoiler, we're probably going to clear cut a little bit. This portion of the project will be led by our social science co-PIs, Sonia Sachdeva and Krista Straub, who will lead the development and delivery of multiple social science methods to sample attitudes and values that people have around these things. Our intended sample population includes landowners and managers from around the region, and we have the aspiration to sample public perceptions about climate adaptation as well. So in summary, we're really excited about this new project, working to co-develop this research with commercial forest managers. The first entries in these stands will likely occur in the winter of 25 and 26, and we ask that you stay tuned for opportunities to come visit us in the field and for other project updates. And I'll leave my contact info up here for just a minute, but I'll happy to take any questions.
Is that a graph of forest or species composition by percent basal area or TPA?
Basal area.
Are you just going to be looking at actual removals, or are you actually going to look into different possible harvest systems and the validity of each one?
I think ideally we would have all the stands harvested using the same systems.
I get the moderator. How are you going to source genotypes from seed sources that are future climate adapted? What's your methodology there?
It's a great question. I think we're looking at collecting seed because the first entries won't go in for another year and a half, we have the opportunity to collect seed soon and work on rearing those in a greenhouse. But we're also, I should mention, we're working with the TransX project, which is based out of the University of New Brunswick, will also be taking place on the PEF. It's another sort of climate-focused planting study, so we'll be able to collaborate with them as well. Yeah. Okay.
More questions?
Thanks.
Great. Thank you. All right. Next, we have Lucas Harris from here at University of Vermont. Here he is. Going to be talking about sapling recruitment as an indicator of carbon resiliency in forests of the northeastern United States.
Just a minute.
All right, thank you. Hi, everyone. I'm a postdoctoral associate here at UVM, working in Tony D'Amato's lab, and I'll be talking about some ongoing work of ours in collaboration with Chris Woodall of the Forest Service, in which we're taking a deep dive into tree regeneration patterns using forest inventory, FIA data, and trying to link it to potential outcomes down the road, in this case, carbon storage. So these days, there's really widespread concern about tree regeneration patterns, both nationally and here in New England. concern both about the abundance of regeneration, whether it'll be sufficient to restock stands in some case, but perhaps more relevant to our region, concerns about the species composition of the regeneration layer and what it might mean down the road for our forests. And there's really complex reasons behind this, climate change, non-native species, heavy browsing, changing disturbance regimes, the list goes on. But I would argue, no matter the causes, there's really a lot of space for us to take our tree regeneration assessments to the next level and really try to link seedling patterns that we're seeing on the ground now to near-term potential outcomes, like how well seedlings survive and how well they're recruiting to sapling and eventually tree size. And this is a space we've been working hard at over the past couple of years. We've published a couple different methods to get at these outcomes using FIA data. And now we're trying to take the next step beyond that, which is to take a look at seedling patterns and assess potential implications for forest health and for key services like carbon storage. So in the process of thinking about tree regeneration from a carbon perspective, we came up with this notion of carbon replacement, and that's illustrated here. So if you imagine a stand, storing a certain amount of carbon, and there's some sort of disturbance that reduces live tree carbon stocks, well, tree regeneration is going to have an important influence on how that stand recovers over time, and that's going to shape, the carbon sequestration trajectory and eventually carbon stocks down the road. There's potential to, kind of just replace carbon stocks lost in the long run, and we're calling that carbon replacement. There's maybe an opportunity in some stands to shift to, a higher carbon state. Of course, that may not be good for ecological integrity or, other values in our forests, so I'm not saying that's necessarily a good thing. And there's potential to perhaps shift to a lower carbon state in some stands based on the composition of the regeneration layer, in which case we might want to consider targeting these stands when we're managing for improved regeneration. So our goals in this work were to explore this concept of carbon replacement using this detailed FIA regeneration data set called the regeneration indicator, in which seedlings are tallied in 6 different height classes instead of the traditional single size class used by FIA. And we wanted to ask the question broadly about, what do seedlings suggest about how forest carbon stocks might change in the future? And this is across, this entire northern region. So our approach is a little complicated, but I'll walk you through briefly. We're using this detailed tree regeneration assessment with 6 different height classes. We're feeding that into models that predict the likelihood of sapling recruitment 5 to 7 years down the road using a method we had already developed. And we're using that as kind of a metric of the species composition of the seedling layer. Then we created models to predict live tree carbon stocks and also what we're calling total above ground tree carbon stocks, which includes snags and logs, as a function of current tree species composition and other factors. And then we're using those models to generate 2 sets of predictions. One set of predictions uses current tree composition, another set uses seedling composition, and we're essentially comparing the 2 head to head. If the carbon stock values are similar, we're calling that kind of a carbon replacement scenario. If seedlings imply greater carbon stocks down the road, we're calling it carbon gain. If trees imply greater carbon stocks, we're calling it carbon loss. And we found some very interesting patterns when we broke things down to these, carbon gain, carbon replacement, carbon loss areas based on tree seedlings. Don't have time to go into all the results, of course, but one kind of interesting thing that stood out right off the bat, areas that were poised to lose carbon based on seedling composition tended to store a lot more carbon currently, although they weren't actually any older in terms of stand age than stands that were poised to gain carbon. So putting 1 and 1 together there, we basically found that our most productive stands with currently high carbon stocks are also the most vulnerable to potentially losing carbon down the road based on regeneration patterns. And when you take a look at, what forests those are, our northern hardwood forests, maple, beech, birch, and oak hickory forests, we're more likely to, lose carbon based on seedlings than other forest types. And some of the tree species that were associated with the highest carbon stocks, like sugar maple and oak species, were underrepresented in the seedling layer relative to the overstory. So what we're trying to do, kind of broadly speaking, is to use these tree regeneration assessments to try to peer into the crystal ball and take a look at what the future might look like and come up with metrics that might be useful when managing for regeneration. And this carbon replacement notion is one such lens through which you can view regeneration patterns. But I also wanted to make the point more broadly that I think there's a lot of space for improved regeneration assessments to help guide management. We're facing some big picture questions moving into the future. Where and how do we manage for improved natural regeneration? And a lot of folks are talking about tree planting. Where might tree planting have the greatest marginal benefit based on natural regeneration patterns? And we're excited to say we just received a grant from the Northeastern States Research Cooperative to continue this FIA-based work. So we're really excited to take the methods that we've been developing and apply them in the context of our northern forests. Thanks everyone for listening. Happy to take questions. Yes.
When you're inventorying, what season of the year do you do your inventory work?
Gosh, well, it's all FIA. So I think it's the summer season that they're.
The question is that if you're looking at the forest during the growing season, I know that most foresters cruise in the winter, and it's a great time to not know what's on. You can ignore the forest floor when it's always dead when you're there. So I was just curious.
Yeah, I think it's the summer season. It's, part of this more detailed vegetation assessment. It's on like 1/8 of all FIA plots. Yeah.
I'm sure you did consider it, but didn't mention, but, what I see all the time here in Vermont is really good regeneration, but it's all beach.
Mm-hmm.
It's a lot of get diseased, and it's,
Yep.
do you take that in consideration in this study?
Yes, we absolutely saw that there was a lot of beech. It was overrepresented, particularly in those larger seedling size classes in the sapling layer, and that was associated with somewhat lower carbon stocks than if you had more sugar maple, for example. Yeah, in the back.
Yeah, so, this FIA data is across a really broad region, and there's a lot of factors impacting the region, right? So beech bark disease is one of those. You mentioned that sugar maple and oak were species missing from that regeneration level, which are both really prone to browse. Have you started to break out these actual proximate factors that might be causing regeneration failure, or right now you're just still looking big picture?
Yeah, we haven't really started to get into the causes yet. We're really just trying to develop metrics to look at, where we might want to be more concerned versus less concerned about regeneration patterns. And then, of course, what the causes are and what the management prescriptions might be would be, of course, like site and region specific. Yeah.
Take into account losses due to predatory browsing?
Yeah, not directly. Not directly. There's sort of there's kind of a general indicator of browsing intensity in the FIA data set, but it's not considered a really reliable indicator of how much browsing there actually is. So it's not something that we've gotten directly at in our current work, but it's definitely something that we want to try to get at in our future work to try to develop some sort of better proxy for browsing intensity, because we think it is, so important for successful regeneration. Yeah.
Has any of this information been published yet?
So we have those two methods papers, one looking at sapling recruitment and one looking at seedling survival from height class to height class. And this current work on carbon replacement is in review right now. In review.
And how would I access those first two?
Well, I could send you links, but yeah, one is in the Canadian Journal of Forest Research, and one is in Ecological Indicators.
All right. Thanks, Lucas. Okay. Allison, you're up here. That's great. All right, next we have Allison Foster from the University of Maine talking about cost-effective and efficient monitoring and management of Maine spruce budworm outbreak.
All right. Thank you so much. Good afternoon, everyone. Welcome. My name is Allie Foster, and today I'm really excited to share my master's thesis research with y'all, looking at cost-effective and efficient monitoring and management of Maine's spruce budworm outbreak. To begin, spruce budworm is a native forest pest in the Northeast United States and Canada that defoliates balsam fir and spruce trees, and it has cyclical outbreaks every 30 to 60 years. The last outbreak in the 70s and 80s cost the state's economy hundreds of millions of dollars, and there's been an outbreak in Canada observed since 2013, and defoliation has been observed in Maine since 2019. And experts are unsure of what effects the coming spruce budworm outbreak will have in Maine, but there are economic impacts projected from $397 million to $794 million. So it's really important to be proactive in monitoring and managing for this pest. All right. Typically, spruce budworm is monitored through field approaches, looking at pheromone traps and L2 branch samples, L2 meaning the second instar larvae of spruce budworm. And the Maine Forest Service coordinates a statewide pheromone trapping network effort. However, over the past couple of decades, the use of remote sensing in forestry has increased greatly, especially for forest health monitoring. And remote sensing can be anything from satellites up in space, such as Landsat and Sentinel-2 from NASA and the European Space Agency, as well as drones that are flown by forest managers over their own land. So there are a lot of tools that forest managers can use to monitor spruce budworm, but there's a clear need to understand how all of these approaches can work together and provide forest managers with information that's going to be helpful to them. So in this research, we sought to understand the cost effectiveness of different monitoring approaches, including field approaches and remote sensing, to look at the cost effectiveness of these approaches. And this table on the screen shows an overview of the 3 different remote sensing data that we used: Sentinel-2 imagery, PlanetScope imagery, which is commercial imagery, as well as using a drone camera. And for each approach, we quantified the cost of labor, capital, et cetera, and we did this by talking with forest managers in Maine and literature review. So moving into some results, we found that Sentinel-2 is the cheapest monitoring approach on a per square kilometer basis, whereas a drone is most expensive. However, we ran a lot of different sensitivity analyses looking at manipulating different variables such as the discount rate, and also taking into account what if you don't purchase a drone and what if you rent a drone and other things like that. But through this analysis, we really found that a drone was going to be the most expensive option. And it's important to note that the most influential costs in our management in our analysis were the labor costs, since they accrue on an annual basis. For these remote sensing-based approaches, the labor comprised about 30% of the total costs, whereas field sampling, it was 90%, and makes sense based on all the actions associated with that. And in this project, we proposed this new integrated monitoring approach that combines remote sensing and field sampling to look at spruce budworm hotspots and how to get information from there. So this figure on screen, the blue depicts this remote sensing framework of obtaining the imagery and doing the change detection, whereas the field sampling looks at the pheromone traps and L2 branch samples. And what's really important to note is that the timing of these two approaches line up really well. Specifically, remote sensing and the pheromone traps are utilized during the growing season, whereas the L2 surveys are done when spruce budworm is overwintering. So the L2 surveys can provide supplemental information to forest managers during the winter to determine the hotspot extent. And as you can see on the screen, the integrated approach comes out to a cost of $168 over this 10-year project period per square kilometer. So it encompasses the cheapness of the Sentinel-2 detection approach with the effectiveness that you would get from the field sampling to really provide that information to forest managers. And this integrated approach can also be used from different scales, from small landowners to large landowners. And since Maine's forest community is incredibly diverse, it's really important to think about the applicability of these results. This monitoring workflow is adapted from the U.S. Forest Service general workflow, but specific to spruce budworm. And this workflow can be used annually, but looking at the bottom half of the graphic, it depicts some of the tools that forest managers would use. So, for example, to detect the spruce budworm and kind of start off, forest managers may choose to look at the latest defoliation maps for the last 3 or 5 years, as well as susceptibility maps, as we know that balsam fir and spruce trees are going to be more susceptible as opposed to other tree species. And as we move forward, we're going to continue to face challenges from forest pests and diseases, but really using this integrated approach and combining remote sensing and field sampling can provide timely information and help effectively manage forests in the face of an outbreak. So to wrap things up, we see that there's a trade-off between cost and accuracy. When we use Sentinel-2 data, it may be a bit cheaper for us, but we get that information on a larger scale. And whereas flying with the drone, it is going to be a bit more expensive, but there are obviously advantages to using a drone, such as drones and PlanetScope can provide enhanced spatial and temporal resolution. And like I said before, spruce budworm is seen on a landscape level, so flying a drone to cover 100 acres of forest land may not be the most cost-effective approach, but if you're using a drone to really look at specific hotspots, it can be useful. But really, this integrated monitoring approach is promising and providing a cost-effective way for forest managers to monitor spruce budworm. And next steps, once we detect spruce budworm, how do we manage it? So there are a lot of research being done in the Northeast and Canada looking at spraying BTK, which is a biological insecticide, as well as pre-salvage harvesting. So I'm in the process right now of doing a management analysis, looking at the different costs and benefits of that, as well as needing to support existing monitoring infrastructure with the Maine Forest Service, as well as the lab processing for L2 samples at the University of Maine. So finally, thank you to my advisors, Dr. Adam Degno and Dr. Parinaz Rahimzadeh Bajirian, the Cooperative Forestry Research Unit, Maine Forest Service, and all the funding agencies. So thank you so much, and I'm happy to take questions. Yes.
Can you describe a little more the data that you're looking at on Sentinel-2? Is that pixel by pixel scoring or visual?
Yeah, so for Sentinel-2, for example, some of the costs we quantified were going to be the processing costs associated with the imagery, but also the capital costs for Sentinel-2 are really only looking at some of those computer and different capital costs like that, as opposed to Planet Scope, you're paying for imagery. But for Sentinel-2, the data that we looked at was those 2 tiles of imagery that would be downloaded to do the change detection. If that answers your question. Thank you.
Is there a correlation between the June-July pheromone, which is male, and the L2, which is the overwintering population?
We have not really looked at the correlation between that data, but I know the Maine Forest Service has state reports that really detail that information out. And since the pheromone traps provide information on some of those male moths, and the pheromone traps provide specific information, or the L2 branch samples provide information on the larvae, it does provide different information for the landowners. Thank you.
All right, up next, we have Taylor Lucy from the University of Massachusetts, I was going to say Maine, University of Massachusetts, assessment of wood quality and deterioration rate of hemlock trees with hemlock woolly adelgid infestation.
I think I got the arrow keys working. Let me just double check that. Yeah.
Okay. All right. Okay. Thanks for sticking it out. I think I might be the last person to go, and I'm sure everyone's eager for a post-conference beverage or at least some fresh air. So this is some work that we started last summer. It's very much preliminary research, and I work with Dr. Megan McLean, who's also here today, and then one of our collaborators, Michaela Musa, who's with the Building Construction and Technology Department at UMass, and then Dr. Dave Orwig, who is giving a talk tomorrow on HWA. So jump right into it. So our field site is at Harvard Forest, which, if you're unfamiliar, is in Petersham, Massachusetts, in central Mass, just northeast of the Quabbin Reservoir. And HWA has been present there since about 2009, and the trees were fully infested around 2012. Oddly, that was the first year that I worked there as a field tech. I didn't bring it with me, I promise. So our research questions, as the title suggested, we're interested in the internal decay rate of standing infested hemlock trees in the forest. At what point in the decline of a hemlock tree does it make sense to harvest for a long-term wood product like mass timber or not? And finally, what are the short-term carbon trade-offs between in-forest hemlock decline and mortality versus harvesting for long-lived wood product? Obviously, I only have 7 minutes, so I'm just focusing on this first one. And as I mentioned, we're in the preliminary stages. Just wanted to give you guys a sneak peek of where we're headed. So for our methods, we did qualitative crown assessments. This involved literally walking around with Dr. Orwig, who's an expert at Harvard Forest, and we put these different stands of hemlock trees into buckets of less than 25% defoliation up to over 75% defoliated and somewhere in the middle, so basically the best looking to the worst looking, but again, they're all infested. We had 30 trees per group, so for a total of 90 trees. We also used a FACUP 1D microsecond timer, which is an acoustic piece of technology, which I had never heard of until last summer, but if you're an arborist, maybe you are familiar with it. So this takes time of flight measurements in microseconds, and we averaged 5 readings per tree to get the acoustic velocity. And here's just a schematic of what that looks like. We use the longitudinal method in the center, which essentially you just have these 2 probes that you put in the tree. You tap one of the probes 5 times, you get these readings, and it's basically telling you the amount of time it's taking from getting from one probe to the next. And we did not do this on down timber, that was on standing trees, as I mentioned. We also took short tree cores. We did 10 trees per group to get our dry and green density. So essentially we took the cores in the field, we weighed them, measured them, took them back to the lab, dried them overnight, and then got the dry density and the moisture content. And then we also took DBH measurements. All this work was basically within the forest geoplot, if you're familiar with Harvard Forest, so there's a ton of data on these trees already. But we wanted to be sure, so we took our own DBH measurements, and we were mostly interested in pole timber and saw timber size trees because, again, we're interested in the wood product potential as well. So And I mentioned wood quality in the title, and we're kind of focusing on both here, but how we got to wood quality from all of those measurements is by looking at dynamic modulus of elasticity, or MOE, which essentially is the wood stiffness. You can get modulus of rupture, which is an estimate of the strength from MOE, but we're just focusing on MOE for now. So by doing that, a little bit of math, I know it's terrifying, but you take the distance between the two probes, so for us that's about 1.5 meters, and then divide that by the average time of flight, which we got from the microsecond timer to get acoustic velocity. You can square that and then multiply it by the mean dry density from our tree cores, and that gives you dynamic MOE. And then this is just like straight from our raw data, the average time of flight. This is in microseconds, and this is all 90 points, and this trend shows you that we do have, we were seeing a little bit of a, as the DBH increases, the time of flight was also increasing, which means it was slowing down, and potentially there might be more defects in the tree. And then I mentioned the core samples. I forgot to say that we only took 10 tree cores per group, so that's only 30 tree cores, so you can't do a ton of meaningful statistics with these, but this is how we put them in the buckets of, from best to worst, essentially. And so we did have a slight decrease in our dry density with the worst looking trees. I have some ideas about that, but that is an indicator of potentially there would be less carbon. Again, this is all preliminary research. I'd be very interested if other people have ideas or feedback on this. And then in terms of moisture content, we did have a pretty wide range of variability in moisture content with our worst looking group compared to the best looking group. And with higher moisture content, you can also get slower time of flight readings. It is dramatically impacted by moisture content. So. And then this was from our predicted MOE by DBH between the defoliation groups. And you can see this trend again of the kind of best looking trees having the best stiffness compared to the worst looking trees, so the most defoliated ones. That one actually came out more as like a flat line. Some literature does also suggest that there's a weakening of this relationship as the trees get bigger. So in older stands, you can have more consistent outer wood, which could also lead to a slower time of flight overall. But we did have statistical significance between the best looking and the worst looking trees. So that was fun to find out. And then the middle group was kind of somewhere in the middle, a little less significant. So. And I did just mention all three of these basically, but so we did have statistical significance between DBH and the least defoliated and most defoliated groups. So we can say, I wouldn't say with a ton of confidence again, because this is all preliminary, only 90 trees, but our worst looking trees did have potentially the worst wood quality so far that we're finding because it had higher moisture content and as well as the lowest density. And also this was just a really cool way to use mostly non-destructive techniques, so we didn't have to fell any of these trees in order to find this information, and although it would be helpful to corroborate all of the stuff we're finding. So anyway, it was just a great way to assess the wood quality using these non-destructive techniques. And I just wanted to mention a couple limitations. I've mentioned a few along the way, but we only use the longitudinal direction parallel to the grain, so we could be missing other internal defects if we used radial or diagonal directions. And then we did also exclude microclimate factors, so we didn't do anything to do with the soil. We just, kind of ignored everything else, only focused on the crown for now. And any other external defects, we also ignored that. And I'm sure there's probably some site variability, though all of these plots are very close together. And we need more samples. So we don't have a comparison with healthy, non-infested trees yet. We're really only comparing, in this case, between already all infested trees and what the crowns look like. And that is the plan for this summer. We're headed up to Hanover, New Hampshire, to Fullington Farm Field, and we have some indication that the trees are not infested, but I guess we'll find out when we get there. So fingers crossed for us, and thank you. Any questions? Yeah. Oh.
Is there any relationship that you saw between the defoliation group that the trees are in and the canopy position of those trees?
I didn't look at that. We mostly just wanted to see I guess the rate of defoliation, just looking at how much of it is still there, so how much of the crown is still alive and present. But that would be a good thing to consider. So I did actually just read about that in another study, so thank you. Yeah.
Were you able to control for the history of the trees, like age of release or years since release?
No, I don't. I'm less familiar. I would have to ask my advisor who's in the audience who has more familiarity with the history of Harvard Forest, but no, we didn't control for that. Oh, in the back, yeah.
I know you said you haven't looked at any healthy tree data yet, but hemlock has known defects like shape that are pretty common across the population. And I'm wondering, have you looked yet at even other studies that have looked at the proportion of hemlock that is prone to shape and whether or not that may explain some of the trends you saw?
No, I haven't actually looked at that yet, and that is something that I have been thinking about this whole time. So yeah, something definitely worth looking into. We're also really interested in looking at longer core samples just to see if we can, I guess look at all the tree rings and see if we have any indication of what growth rates have looked like, and see if it works with what we're finding so far. But yeah, thank you. Great suggestion. Oh.
Do you have a feeling about the levels of defoliation? Is that strictly a function of how long the tree's been infested or not necessarily?
I don't. I feel like, I'm very new to HWA. This was my first project working with hemlocks in HWA. So I feel like I don't have a great indication. Yeah, I'm trying to think, like, even in all the studies that I'm reading, I don't know. I mean, I'm mostly got so focused on the moisture content aspect of this and thinking about how the tree is not probably photosynthesizing efficiently, and that maybe that's what's going on. But I'm really not sure. Okay, thanks.